Lesson 33. Page 151. Major rules of algebra, complex fractions. Most of you know a lot of the major rules of algebra, which is always a good thing. Whatever you add to one side of the equation, you add to the other side. Divide, multiply. Whatever you do to one side, you do to the other. Whatever you do to the numerator, you do to the denominator. Okay. Couple things that are true. Maybe we can put them into perspective for you. When you are not given an equal sign in a problem, that means you're not solving for the variable, because you cannot solve for a variable unless you have an equal sign. Unless, of course, I give you 3x plus 6, and I tell you x is 3, so what's the answer? You can do that. But you cannot solve for a variable if you're not given an equal sign. It also means that if you're given a fraction, you cannot eliminate the denominator unless you have an equal sign. So if I have x over 2 equals 6, because there's an equal sign, I can get rid of that denominator. I can multiply this whole thing by 2, and I can get rid of the denominator. I can cross multiply and get rid of the denominator and solve for x. But if there's not an equal sign, I can't get rid of the denominator. All I can do if I'm given a problem without an equal sign is to simplify. Combine like terms, bring things together, find common denominators, that kind of thing. Okay, so let's look at some of this stuff. 4 over x plus y plus p over y over x. If I was given an equal sign, could I solve that? Yeah. It's kind of a tricky question because it depends on a lot of things. I could solve for x, I could solve for y, I could solve for p. But I wouldn't be able to give you a numerical answer for each one of those because I have 3 variables in one equation, if I had an equal sign. Okay, so at this point, bless you, all I can do is find common denominators and try combining like terms. I'm so caught up with, wow, she's still sneezing.
That's like 18 sneezes.
Okay, so you're given that kind of an equation or that kind of an expression. What can you do with it?
Leave it be.
Simplify. Oh yeah, Erica's like, the next problem. All right, so let's say I want to simplify it, Erica, and we're not going to let it be. What is the only thing I can do? Find common denominators, put those two together, and be happy with whatever I get. So what is the common denominator?
X plus Y.
Okay.
No.
I heard the right answer from a couple of you, and then I heard, so. All right, so we're going to find common denominators. How do we find the common denominator?
Multiply them by each other, pretty much.
Okay, one of the key things is that right there, putting that in parentheses. They do not split up. Okay? And what do I multiply top and bottom by here?
X plus Y.
Okay, so I'm given 4x plus py times okay. So at that point, what can I do? Okay, Erica wants to leave it.
Of course.
Why do you want to leave it, Erica? You'd rather not do it. Okay.
I'm guessing you could do some distributive properties and under there.
We could distribute that py, we could distribute the x, yes?
If you distribute it, you're not going to be able to combine anything anymore.
So what's the point? Yeah. You're just wasting.
So I was
Lead.
right, we leave it.
You are right. Wrong reason, but right answer. Okay.
Let it be. Let it extra credit.
Sometimes
What?
you're going to be given some things like this. All right, whenever we have multiple fractional signs like that, how many do we have?
3, 4, 2,
4.
4.
I have 4 horizontal lines up there. Whenever you have multiple horizontal lines up there, division signs, you have what is called a complex fraction. As far as dividing fractions, what you want to make sure of is that both in the numerator and denominator, you have only one denominator. Does that make sense? So, down here I've got one denominator. Up here, I have 2 denominators. So I can't divide yet. I can't do this problem yet. I've got to have common denominators in the numerator and in the denominator in order to combine these things. Yes, Kendra?
Oh, never mind.
So we're trying to get one fraction over one fraction. Here I have 2 fractions over one fraction.
So don't you like multiply the numerator and the denominator by the opposite of the a over y?
Well, not yet, because I want this to be one fraction.
Oh yeah.
So what am I missing over here?
X.
Okay, and what do I have to put in over here?
Nothing.
Okay, and that equals what? X squared. Okay, one fraction over one fraction. Now I can invert multiply.
And then if you multiply the y's would cancel, right?
Yes, your y's will cancel out in this one. So this cancels with this.
So it would be x squared plus 4 over x over x.
Yes.
It's crazy when words start going into math.
All right, so let me give you one to try. Plus m over y all over x over a plus m. Okay, so give that one a shot. See what you come up with.
You can calculate the mass. Give it a go.